And we're also going to alternate between addition and subtraction, and we're going to use mixed numbers. I'm going to refer to this clock as my model for thinking about these fractions. And this is a string, so there should be lots of nice patterns popping up. You might want to pause and work ahead, solve this, and then compare it to how I work through it. But I'm going to get started right away. So here, I think of this as being 18 hours, right? I'm going to write 18 hours. And how many minutes? Well, third, again, if we split our clock up into 3 equal pieces, each third is 20 minutes. And if we cut it in 6 pieces, well, each 6 would be 10 minutes. So here it's like having 18 hours and 20 minutes and 4/6. Well, 4/6, every 1/6 is 10 minutes, so 4/6 is 40 minutes. And there's a nice little hour, right? And so 18 hours plus another hour is 19. So we can say this is 19. Next, we're subtracting. So really we have the same problem, except now we subtract 8 from 10, so that's 2 hours. And then we are going to subtract a 4/6 from 1/3. But actually, you know what I'm going to do? I could do it that way, but I think I prefer to say that this is 10 hours and 20 minutes. This might be easier. Let's see. Minus 8 hours, just so I can see it, and 40 minutes. Okay. Well, if you took 8 hours from 10 hours and 20 minutes, you'd have 2 hours and 20 minutes. Right? So that's 2 hours and 20 minutes. And then we're taking 20 minutes. Another 40 minutes away. And this is kind of difficult to visualize, but that would give us 1 hour, for me at least, and 40 minutes, which gives us 1 and 4/6, 40 out of 60. And we could check that by thinking, well, does this make sense? If I add an hour and 4/6 to 8 and 4/6, do I get 10 and 1/3? And the answer, I think, is yes. 8 and 4/6 plus 1 is 9 and 4/6. Plus another 4/6, well, let me just write this over here. No, I'll write that here. 9 and 4/6, I'm just checking. Plus another 4/6, what's that? Well, 4/6 and 4/6, what's that? Well, each 4/6 is 40 minutes. That's 80 minutes, right? 80 minutes plus 9 hours is 10 hours and 20 minutes, or 10 and 1/3. So that does work. And you notice that, okay, the clock model here is taking forever to think about. It's really tough. It's not very helpful. But I would still argue that everything I'm doing here makes sense. It's intuitive. I'm not randomly plugging in an algorithm to solve this, so it does keep me in check. Moving on here, now we're adding 10 and 1/12 and 9 and 11/12. 1/12 and 11/12 is 12/12. That's an hour. 10 and 9 is 19, so here we have 20 hours altogether. And all I did there was count the amount of whole numbers we have. Now we're subtracting. All right, maybe not as easy, but we can do this. So 10 and a 12th is what? Well, a 12th of an hour is just 5 minutes, right? That's how the clock is split up. So if I have 10 and a 12th minus 9, that would give me 9 and a 12th. Oops, and a 12th. But we're also subtracting 11/12 from that. So what does that mean? Well, here we can use the clock, at least I'm going to use the clock, to turn back. So here we're at 1/12, right? If I go back 11/12, I go back here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, it brings you back to that 2, or the 10 minutes. So 9 and 1/12, if you take another 11/12 away, right, it brings us back to 8 hours and 10 out of 60, or, right, 2/12, or 1/6. So here I get 8 and 1/6. So, wow, that's actually pretty tough with the clock model. And these kind of problems, I'm wondering, is this model even efficient, or is it just too nasty to think about? Well, we were able to handle it by looking at the model just to make sense of it. Right, 10 and a 12th. That means we start at 10 hours and 12 minutes and 5 minutes. We go back 9 of those hours. It brings us back to 1 hour. Oh, I made a mistake. Oh boy. I'm glad I checked that. 10 minus 9. 10 and 1/12 minus 9 brings us to 1 and 1/12. Sorry about that. And then we go back and we're left with the 6th. Right? Because here we are at 12th. Right? We go back 11 of those 12ths. That leads us just back to this right here, which is just 1/6 of an hour, or 10 minutes. Well, perhaps that would have been easier if I actually wrote it out in terms of minutes, and I'm not sure. Anyway, how can we check? We want to add 1/6 to 9, 11, 12. And maybe that was an easier way of thinking about it. 1/6 is like 2/12. If I add 2/12 to 9 and 11/12, I do get 10 and a 12th. So perhaps I should have subtracted this by saying, how many 12ths, yeah, this makes more sense, sorry about this. How many 12ths do I take away from 10 and a 12th to get to 9 and 11/12? Well, imagine the clock spinning around and around. Eventually I'll get to 10 and a 12th, right? But 9 and 11/12 is just 2 hops back, right? 2 12ths back. So really the difference between 10 and 11/12 and 9 and 11/12, 10 and 1/12 and 9 and 11/12 is 2 12ths, or 1/6. Oh boy, I hope I didn't just butcher this video by talking for a while there, sorry. Now we have 1,001/3 plus 999 and 4/6. In every step so far we added, you might notice that the fractional parts add up to an hour. The same thing is true here. 1/3 and 4/6 is another hour. So really here we have 2,000 hours. So now I'm going to try a similar strategy that helped me a little bit here and apply to this one. How many times do I have to jump in terms of thirds to get from 1,001/3 to 999 and 4/6? Well, 4/6 is 2/3, right? So how can I say this? If it's, are we right? 999 and 2/3. Okay, I'll use my clock model, even though it's getting filled up pretty badly here. So here is the model being split in thirds, right? So we can just think of for a moment that if we're sitting at 1,001/3, 1,000 hours spinning, 1/3, we end up here. Okay, well, to go back to 2/3, we have to go back a third and then another third. You see that? This is 2/3 right here. So to get from here to here, we have to hop back 2 1/3. So the only difference between these two big numbers is just that. It's 2/3. Right, to get from, and that makes sense, if we add a third to this, we get 1,000. If we add another third, we get 1,000 and a third. So the difference here is 2/3. Whew, alright, those were, I guess they were tough for me. I'm going to say that because I was using my intuition the whole time, which you might have noticed is all over the place. If I just plugged in a standard algorithm in here, sure, it would have been faster. And I would have felt like it was easier. But maybe I would have had no sense of what the answer meant. That's why we're going through this. I hope it's helping a little bit. Thanks.